What is up? In this video, I'm going to be going over the 2.4 Plinko Lab simulation, and I'm going to show you how to do this assignment. So, if we're in Canvas, we're going to go to the assignment here, 2.4, and that's going to take you here. So, I'm going to run you through how to do this assignment. And first, you got to download the worksheet and run the simulations in the given scenario. So, first, click this worksheet right here, and then you're going to click Make a Copy, and that will take you here. So, first thing you want to do when you do this is you want to click the share setting. See how it's locked? If you submitted this, I will not be able to see it. So you want to click that and make sure it's either Metro East or anyone with link, but not restricted. So I'm going to do anyone with link. And what you're going to see, that up here puts it here. And now if it's showing this globe instead of the lock, that means when you submit it, I'll be able to see it. So what we're going to be doing here is you're going to run some simulations here. So step one is you got to go to the PhET lab simulation here. So click here and you want to go to lab, okay? Not intro, you want lab. So lab is what we're going to be running here, and that's going to take you here. So once we are here, see we have four different simulations that we're going to be running, and then you're going to answer some questions at the end. So the first one, you just got to follow along with the directions. So here you have your rows, your binary probability, the theoretical mean, and the actual mean. So rows we want set to 25 rows, and this is going to be the same for each simulation. Binary probability, that just means if a ball drops, right now it's set to, it has a 50% chance to go right or a 50% chance left. If we tilt it, and you see what it does here, let's say we tilt it to 0.75, that means there's a ball drops to each one of these, there's a 75% chance it's going to go right, and only a 25% chance it goes left. So if we drop these right, see it's going to start more filtering here to the right and not the left, because each one of these little pegs here, it automatically tilts the probability 75% going to the right. So that means it's very low chance that any ball will make it over here to the left. So that's what the binary probability means. And then right down here, N, that means the number of balls that have been dropped. So this is what we're really going to be changing with each simulation. To restart a simulation, you want to click here. And if you click this ideal thing, that's the ideal, like if it went purely based off the math, it should map out perfectly the blue, fill in perfectly the blue. So we're going to restart it, and we're actually going to do simulation one. So let's follow the direction. So 25 rows. So we're going to set our rows to 25. And then we're going to set our binary probability. Just keep that at 0.5. We want to keep this at a 50-50 because we're trying to show how the normal distribution works. So for our first simulation, we're going to roll 10 balls. So it says roll 10 or n equals 10. And again, that's going to be right here. So if you want to do one ball at a time, so for a limited amount, you want to just do one at a time. So just click and it drops one. If you click this, it will drop many, but for 10, we're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we drop 10, and we'll go to our ideal. So based off of this, right, based off pure math, you're going to see that it should fill in the blue. As you can see, we did not roll very many balls, and it really does not map the blue very well at all. So right here, we have our theoretical mean. That's like based off pure math, what the mean should be. So let's now start filling that in. Or actually, first, take a screenshot of your simulation. Make sure you show proof that you ran it. So here's the screenshot. And then I'm going to insert that photo right here. So delete this, and then to insert a photo, you're just going to go insert image, upload from computer, and then however your computer screenshots or wherever that saves them to, why don't you click right here. And as you see, the simulation is intact there. All right. So now that we got our simulation there, now you're just gonna fill in these. So the theoretical mean is gonna be right here. So based off of this, a 0.5 probability with 25 rows, the average ball should be in between bin 12 and 13, so 12.5. So 12.5, the theoretical standard deviation, right? Because again, we're trying to map a normal distribution, would be 2.5. And what you're going to do is you're going to see actually what the difference between the theoretical and the actual of these are. So the actual mean was 11.7, not 1.7, but 11.7, and the actual deviation was 3.302. Okay, so now what you're going to do is you're going to find the difference between the mean and then the difference between the deviation. So you're just going to go the actual mean 11.7, or you can do it this minus this because sometimes it's going to be higher. Whatever, if it gives you a negative or a positive, it will be the same difference. You just have to, I would just write it always as a positive. So for instance, if you go to a calculator here and you go, I'll show you what I mean here, how the difference will be the same. So uh, the way I have it is you do the actual minus the theoretical. You could do it reverse and it will give you the same answer, but we'll go 11.7 minus 12.5, and that's going to equal zero point 0.7 minus 12.5. And see, that's going to give us minus zero point 0.8. So you want to express this as a positive because the difference is just there's zero point 0.8 difference between the two, 0.8. But if you did the opposite theoretical minus the actual, give you zero point 0.8, it will just be positive. So if I did 12.5 minus 11.7, it's going to give you C 0.8. So either way you do it, it's going to give you the same answer. Just make sure if you get the negative answer, just write it as positive because that just means there's a zero point 0.8 difference between the actual mean and the theoretical. And then we're going to do the same thing for the actual standard deviation minus the theoretical. So here we have 3.302 minus 2.5. So let's do that. 3.302 minus 2.5. So we have a theoretical difference of 0.802 between those. So difference is pretty big between the mean and the deviation from the theoretical to the actual. So what this simulation is going to show you is that the more balls that you roll, the closer that the theoretical and actual will get to one another, to where if you rolled 1,000,000 balls, the theoretical mean and the actual would be nearly identical, and same with the deviation. So the second scenario, we're going to roll 100 of these. So let's restart it. And we want to keep our settings the same. So 25 and zero point 0.5. And we're now just going to roll 100 of these. So it doesn't have to be 100 on the dot, but get close to 100. And like I said, it does not need to be exact. And we'll see how much closer the theoretical and the actual mean are apart from one another. So, all right, that's going to be more than 100, but you don't have to hit it exactly. We rolled 142, and now let's see the difference. So let's screenshot, and now let's insert the photo of the 100 roll simulation. And there's our 100C, 142. So the theoretical mean still was 12.5, and the theoretical deviation still was 2.5. And the actual mean we can see here was 12.81. So see, still quite a bit closer than the last one, and the actual deviation was 2.633. And so you can see here the difference between the mean. We're going to go 12.81 minus 12.5, and that's going to be a difference of 0.31. And then the actual deviation minus the theoretical. So we got 2.633 minus 2.5. And that's going to give us a difference of 1.33. And so you can see already the differences are much closer. So we had um, zero point 0.8 difference for the mean. And actually, our standard deviation was a little bit further away, but still pretty close. Actually, no, this one was, sorry, it's not 1.33, 0.133. That was my error. So yeah, both are much closer. So we had a difference of zero point 0.8 and zero point 0.8, and now we had a difference of 0.31 and 0.133. So we're getting a lot closer. So on the next one, just for time's sake, I'm not going to do these because I think by now you know what you got to do is you got to roll 1,000 balls for the next simulation and then 10,000 for the next one. And because that will take some time, what I would do is I would just restart it and it's instead of dropping what you I would do is I just roll them and I would just get up and leave. You know, leave for a few minutes and come back. And like I said, it doesn't have to be exactly 1,000. 1,000, you can probably sit here and watch it. It will probably only take about a minute or two. And you know what? I'm actually going to just go do the 1,000 one so you can see how long this will take. We're already almost at 200. And so what you'll see is as we roll about 1,000, the theoretical mean and deviation will be even closer. Oh, sorry, I made an error there. We want to keep our settings at 25 rows. If you don't do that, that's okay as long as you're doing the um, differences. But that's an error. Again, I'm keep making errors on these. But yeah, you want to make sure your rows are at 25 so you can see how the difference will get closer with the more balls you roll. So here we're doing 1,000. If you want to get up and leave and go get a drink of water or something, you can see it doesn't go. It goes pretty fast, and you don't have to hit 1,000 on the dot. If you're a little bit lower or a little bit higher, that's fine. But you can see here it's starting to map much closer to the blue. And I'm guessing that after 1,000, the theoretical of both will be closer than our previous two simulations. And so right now I'm just talking to fill the time here. Let's go back to our sheet. So we're on simulation 3, right? And we're trying to hit 1,000. And we know our theoretical is going to be 2.5 because it's the same settings. Or sorry, 12.5. And theoretical deviation is 2.5. And so now we're just going to find the actual mean and deviation. And we're getting there. We're getting there. Seems like it's slowed off a little bit, but that's why when you do the 10,000 one, I'll tell you, just set it, go up, and go do something else for 5 minutes. If it's way over 10,000, that's fine. If it's like 100,000, and we'll see if somebody wants to do like 100,000, as long as it's over 10,000, I'm good with that. If you want to just let it run for like an hour, you can see how close it will be. But just make sure you get it close to 10,000 on number 4. And you see we're almost at 1,000 now. And you can see already how close the theoretical are to both. And again, you can see what these numbers indicate. That means 124 balls have dropped in bin 11, 139 in bin 13. And again, this arrow says there should be roughly equal amount in 12 and 13 if you're going based off the theoretical probabilities. And so it's over 1,000. So let's see here. And let's go ahead and screenshot. And now let's upload that photo in here. Okay, so there's our third simulation. So you got 10,095, and so the actual mean was 12.633. 0.56, and the actual deviation was 2.483. And so the mean difference was 12.56 minus 12.5. And so that's going to give us a difference of 0.06 is all. And then the actual deviation was, we're going to go 2.5 minus 2.483. And that's going to give us a difference of 0.017. So again, if on these, I would just do these on a calculator just in case if you're not confident in your mental math. So we had 2.5 or 2.5 minus 2.483. And that's going to give us 0.017 as you see. So look at our differences for the more balls we get. So the idea of this is the more that you roll, the closer these will get to the theoretical and the actual. And if you were to roll like a million, or a billion, they would be almost identical. So simulation 4, you're going to roll 10,000. Like I said, best advice is to just start the simulation. So go here, click the many balls. One error that somebody might make is that they click one ball and leave, and then it will only drop one. So make sure you have it clicked here, and then just get up, come back in like 5 or 10 minutes and see it's at. Again, it can be way over 10,000. That's fine, but then let it run, fill out these, and then the last part is you're just going to answer these questions. Which simulation has the largest gap between the actual and theoretical? Which mean, and then which had the largest between the actual deviation and the real and the theoretical? And then what would you expect if you ran a simulation 100,000? Would you expect these to be closer or further away from the actual ones? So that is how you do the Plinko probability assignment. I hope this video helped explain it, and always reach out or email me if you have any questions.